surfaces of different planets. This guy right here, that's actually a model that NASA did of a star that exploded. So we have these nice 3D pictures, but they're two-dimensional, and the explosions are three-dimensional. So we can show them the three-dimensional aspects by printing it. What else can we do? We can do biology models, so we can do skulls for studying anatomy. I had a student last night do a special skull. Yoda, because I'm astronomy. We can print chemistry models. Anybody chemistry? H2O, hydrogen into oxygens. So these are the same atomic models that they spend about $100 to get. We can just print them for a couple pennies. Make sure
What's the substance in it? What is this? It's a...
Ours, I think it's the same. Ours is it's a corn-based plastic that this particular vendor makes. I don't know if you're using it.
We use, it's called PLA.
PLA, yeah.
It's basically a Lego brick that they've melted down and put into spools. So it's the same thing as Lego bricks. You can make movable parts. So I have a little cube. And then actually rotate this.
Cool.
And everything there is 3D printed.
So you start each individually and then you...
Each individual piece, and then you assemble it. So they get experience with how things fit together and making moving parts. And then the big thing that I've been working on is this. There's a project where a group is working to design prosthetics.
Did you guys, I'm sorry to interrupt, did you see the parade magazine a couple weeks ago? And on the front cover, I gave it to Liz Langren, has that picture. Amazing.
And we can print these. So this is a functioning prosthetic hand, usually for children that have wrist motion but don't have fingers. So they can wear this, and then when they rotate their wrist, the fingers will actually close. So we have to adjust the tension on the fingers to get it all right and perfect. This is a hand that actually, one of my students went to a conference, and she actually paid, I think, like $20 to get the kit and all of the 3D pieces. This is a hand that was printed, I think, actually on a MakerBot. And I wanted to know, can we do the same thing on our little printer bot?
Oh my
We have a slightly different printer. So I printed a giant one. But it's the same thing. Same hand. My students, they actually fixed all the tension on this one. So they were kind of playing a prank on me because I told them that I was presenting this. So can you guess what it's going to do when I read it? Yeah. But we can fix that. The students did that.
Thank you.
So you can compare the two hands. I mean, they're pretty much the exact same thing. This one's just a little bit bigger. This one's a little bit higher quality because that printer is a little bit higher quality. So how much was that one?
$2,500.
$2,500. And this one here was about $600.
Okay.
So you can still get the same functionality. It just takes a little bit longer. Whereas you might be able to print this in a few hours. It takes about a day. Yeah.
Are you putting this on them? I mean, was that
So-
a separate print thing? Or is it something that
So
you
this
just
is
put
something
on
that you can
to-
purchase separately, the little rubber grips. Okay, those are like a couple pennies for each grip.
I
And
just
then-
am really excited. I'm a special education professor here, and this is huge.
What this is here for.
Huge.
And we prototyped and tested to make sure things would work, so I made sure it could be printed in a small little
So
can.
excited. Because these are so expensive. These are so ridiculously expensive.
So here's one that's in the process of being made,
Assembled.
assembled. We've got all the pieces.
Therapy.
Student was supposed to assemble it last night. I think they got busy with making the hand
Yeah.
do the various things. So, yeah, we're working on that too, and testing tension. The nice thing I like about these printers is I showed this to a physical therapy student. They're like, that's really cool, but what if somebody can't move their wrist? Then they can't use the hand, right? So he said, why can't we, can we put a motor in it? And then a little sensor that we can teach them how to flex their forearm muscles. So we can detect when they flex, and then that'll close the hand. Like, maybe, why don't you try it? So we have somebody working on that, on making additions to these designs. And we have people working on changing the way the thumb works. Because right now, it closes that seems a little weird to me. You kind of lose the
The opposing thought.
the opposable thumb.
Oh, yeah.
So I have a student working on taking this design, and all we're gonna do is take the knuckle and just rotate it so that the thumb is out here. Looks a little less natural, but maybe more functional. And then it's a plug and play, and all the people that are printing these can use that as they wish.
What's being printed in there right now?
So our students, we're using it more of an extension of how we traditionally teach interior design. And this project here, this is traditionally how we would present ideas. So our freshmen worked last year on redesigning the entrance to Todd Rivkis's Turtle Lab. We were being highly critical of the design of the lab entrance, which is a wall with a door with a tiny window in it. And so the challenge to the students was, how do you recreate that entrance to exhibit the kind of research that's happening inside the lab?
Wow.
And there are elements that we're teaching that are important to us, like the human body and the way we interact with things, communicating ideas through interior design. So traditionally, a student would work in plan or a top view, maybe a three-dimensional view. What we added last year, and then they might make cardboard models. We actually took these models then, so they went through the traditional design process, but then we took these models and taught them how to use some free computer software to make three-dimensional models in the computer of their designs. And we actually printed out Todd's lab, and then each student designed, and we helped them print out their wall design. And for a discussion in the classroom, we're able to put their wall inside Todd's lab,
Wow.
and we can actually look at it like this. This is another example, same class, different student. And so what was an unintended consequence is it really empowered the students to make something three-dimensional at a high level of precision, which is something that they were challenged with
It's a lot of math.
when we were working like this. There are things that happen too that are not as great. So that's freshman work. In the junior year, we teach a course called Building Technology, where we explore all the things behind the walls in a building, structural, electrical, mechanical. And so the exercise that the students did a couple of years ago for me was to actually build in 3D details as a way to engage in the different pieces that make up the components of a building. And then we made drawings. So the students actually learned through making in the computer, but that was really the extent of where the knowledge stopped. What we can do now is print out these designs and pass them around the classroom, and then the knowledge can get translated to other students in the class. So this is a wood-framed wall that a student designed in 2012, and 2 days ago I just pushed print, essentially, so that we could see this today. These are different components of an elevator shaft. So this is the elevator pit, these are the rails that the elevator rides on, this is the piston that pushes the elevator up and down. This is a cutaway version of the elevator cab itself, the part that we ride in. And that would go in here. And then right now I'm printing out the next level of the elevator shaft, which will snap on top of this and show you the elevator mechanical room. And then we could continue to go up. And these are, I think, ways for students to see things, and we can have discussions about things that are really difficult to talk about when you're looking at a slide on a screen. So we're, like I said, this is really a tool for us, and we don't really know how we're going to use it tomorrow, but these are ways that we're beginning to engage our students in making things or printing things that they've already made.
How long does it take to print?
This
Something
took,
like
these
that.
two printed together, and it was 2 hours and 40 minutes.
Not
This-
what costs,
How much does it cost? A
once you
spool-
got the machine.
A spool of plastic costs in the $40 to $45 range. You really have to weigh them to figure out how much it weighs because they're hollow inside. I'm gonna guess it's under 50 cents for these. If you're making really, really big things, if you're gonna fill up the whole build platform, it's not really economically viable. I suppose for an academic exercise, that shouldn't really be an issue, but it's it's relatively inexpensive. The real cost right now for us is time. So if we have a classroom of 20 students that wants to print
Yeah.
something,
We do that.
and it's 4 to 5 hours each, you kind of, it's like you're baking cookies. You got to get them all kind of batched up to go. And you can load up this thing and print 2 or 3 things at once and push print and go home for the night, let it run for 8 hours, and then when you come in the morning, you can peel them off. And
Don't get paper jams.
Plastic jams.
you do get jams.
You get jams.
Wow.
You get spaghetti.
So we,
We
the
get plastic
university
breaks.
has one of these, or we have more than one?
So you've got to
Interior
think about,
design has one, and physics has 2.
I've got this printer bot, and then I have another one that's a little bit, the previous version.
Okay, the early ones.
So I've got 2.
Our school had one, our tech in middle school. Our tech ed professor had this one, and the students had to work on their drawings and build and all that. And it's just fascinating. That was when they were, that little ones were so expensive, ridiculously expensive in the beginning. Now the price is so ridiculously low in comparison. Everybody needs one. Every department should have one.
We're working on getting a lab
Yay.
of 3D printers. We submitted a grant for about 15 printers, 15 of these.
Especially when students are setting up.
And on the library, did you work with the library on that grant?
I
Or
did
just
it,
with Robin?
but they're working on getting one too. I worked with Robin to get the lab for us. So we'll see.
And some of the public libraries in the area have 3D printers as well. And so you could, or your students could go and use those resources as well.
Sorry.
That's
I'm
fine.
excited. I
How we
love
went
this.
from having
Love it.
computers
The
that only were in the
possibilities are-
classrooms, to now everybody has their own PC and laptop. Do you foresee someday that everybody will have one of these in their home?
I think the technology has to get a little easier. It's still a little clunky, and what I mean by that is, you have to really understand how the printer works to be able to set up something to print. And it's basically because it's an additive process, you've got to have some sort of support for the plastic to stick to. And almost like, I might be able to give you a set of woodworking tools, put you in a shop, but you may not be able to make a bench. You have to know how the tools work. And so there isn't really software out there that I found that has said, the best way to print this thing that you've designed is to break it up into these 12 pieces and print them, and then this is how you assemble it. That doesn't really exist yet, although there are libraries. So this is some mid-century modern bench called the Nelson bench, and someone designed this in 3D. Well, someone actually designed the bench, right? They own those intellectual rights. Someone designed this in the computer and put it on a online library where you can download and print it. Now they recognize that you can't actually print the bench assembled because there would be nothing for the plastic to stick to. And so they broke it apart into the pieces, and then it's up to me or whoever's printing it to know how to arrange those things on the software to get that thing to print. So there's still that kind of disconnect. I probably spend as much time figuring out how to print things for the students as they spend making them.
It's not exactly plug and play yet, depending on what
What
you're
kind of file, is it a JPEG or is it special, when you see on the computer, you design it, what kind of format is it?
So there STL and OBJ are the 2 file formats. They're open source. Almost every 3D computer software will export to one of those 2 file formats. And then you have to take that and load it into a piece of software like this. And that software actually creates they call it a slice file, but I call them path files. It tells this thing where it has to move and how much ink to spit out. And it's basically giving this the instructions on how to move to make the 3D object. So it cuts thousands of slices through the object and tells this thing how to work. So there's 3 to 4 pieces of software that you have to jump through, which also makes it not very plug and play.
And then you're restricted by the size of the printer,
That's correct.
and you cannot.
Although
You
that-
can print
Oh, that-
some things.
that's bigger than any of these printers because it's printed in pieces. And most of the things that we make can be printed in smaller pieces.
For complicated designs like this, these are professionals that have been doing this for years and have gradually come up to, this is the way you want to print it, print this piece, then print these pieces. Like I can print all the fingers at once, I just have to break it up. And actually, this hand is designed that it could print everything, all would fit on that build plate.
What's the size of
This
the
plate
bed?
is bigger.
It's 8.5 inches wide by about 6 inches deep. The challenge that we've had with it, and so now we can talk about the challenges. The bigger prints, this plastic has to actually stay adhered to the build plate. And when we do larger prints, we get curling on the edges. And so sometimes it doesn't really matter. If you look here, you can, I'll pass that around, you can see a little bit of curling on the corners. If you're doing something that needs to be precise,
On this one too.
we've been having a lot of issues with that when we do really big things.
Is it a depth thing? You know, so
No.
that if you add to the depth of it, you might be able to reduce the curl?
It's
So this base?
something's, it's probably a physics thing. Something's
It's-
happening with the way that the plastic is cooling.
It's more a matter of the cooling and shrinking, and when you're doing a big thing, it cools off fast enough that it shrinks before the upper layers have gotten onto it to weigh it down.
It peels when it's about that thick.
Okay.
And so you know to stop it if you're there to watch it, but if you went home, you don't know.
Is it hot? Is that a,
The only thing that's hot here, there's a little tiny nozzle that looks like the end of a glue gun. That's 230 degrees centigrade.
that's hot.
So you don't want to touch that. But the plastic is cool to touch almost immediately after it comes out of the nozzle.
So my takeaway is that really components are the way to go. And so for our students, getting them to break it into components is a really good
Yeah.
exercise to think in terms of componentry and then attachment.
Absolutely. I mean, I think similar to the way we teach them how to use a drafting bar,
Yeah.
that there are proper ways to use it and improper ways to use it. And it's, or like a woodworking tool. Yeah.
And the connection of the parts.
Yeah.
So it's not whole, it's not monolithic, it's a
And
parts.
there's really positive learning opportunities in that.
Yeah,
Yeah.
I think so.
So it sounds like that these printers are not proprietary. Right now, this one piece of software can take it and put it into the format that each of these different printers by different manufacturers can take it. Do you see that as the trend that's happening? Like there was that thing I sent you about Virginia Tech, and they're really big in this.
I think this is probably, if you want an analogy, it's probably like the digital music experience prior to the iPod. That you had a vendor that you could use that would convert your CD to an MP3,
Exactly.
and then you had another vendor that made a piece of software that would put the music on your portable device.
Right.
And Apple came and made one thing that works seamlessly. So it is all open source. And MP3s, even after Apple, are still open source, right? The file format's still open. But, you know, right now, we could share that. The software needs to know what printer it's sending the information to, because the printers all work differently. Made a shark.
So that printed, and I started it when we got in, we finished in the time we were here. Cool enough to touch right away.
Did it stop when it finished? You didn't have
Yeah,
to stop it?
It stopped,
This has been going for about 2.5 hours, and it's 50% done.
a lot of the companies are starting to lock down things too. Like, MakerBot is starting to lock down their designs.
That's what I was
There's a lot of printers, you can get the printers maybe a little cheaper, and they're designed to be more plug and play, but you have to buy their special filament. It only works with their stuff.
Yeah, sure. I mean,
So-
they're getting it
so they're-
proprietary somewhere.
Locking it down to get their money.
It's the inkjet printer. I mean, there's got to be a
Yeah.
business model, right?
Yeah.
That you get the printer for free, but you're locked into buying their ink for life.
Right.
Like HP,
Right.
they made their money on ink, not on
Absolutely.
printers.
But you'll be able to jailbreak it someday and go with your own rights.
So the printer that I'm using, the guy that made this, he actually got it funded on Kickstarter, for Kickstarter. And he is very big into, it will always be open source, it will always be completely open.
For everybody.
People have offered him billions of dollars to get his designs and lock everything down, and he will not do it. He is very into, he wants his printers in every single classroom, he wants them for
Advancing
teaching.
the
Yeah.
technology,
Yeah.
I think.
the people that really started it, some of the history, somebody wanted the history of it. A lot of the people that started making these printers, they wanted to make them so that you could actually go out and buy, you get a printer, and then you use that printer to print the pieces to make another printer. So self-replicating printers, so you can
Wow.
print all your own pieces. And I can print pieces for this. If something breaks, I can print, fix it. I can print additional pieces, I can print handles, all sorts of things.
Catch one, true, if it's broken, you can't use it for it.
True.
The thing that's interesting, when you look at this component though here, the actual heating element and the feeder, it's almost identical to this. I mean, they're made out of the same materials or, what's that?
So that one has a nice box around it.
Oh,
it's all-
and the next model up that we're looking at for our second one, so we can handle demand peak times, has a heated build plate, which is supposed to help things stick a little better. It's got
Ah.
acrylic sides that will prevent drafts that might cause uneven cooling. And so they make these things and then they say, well, but if you buy this one, you won't have the problem that you're having with this one. And then there's features that you'll never use.
And there's, the nice thing about his is that I think you get support from MakerBot.
Oh, they're phenomenal.
Yeah.
Our graduate student assistant is on the phone with them once a week, and we'll say, this happened, and they say, okay, I'm gonna send you this PDF, or we'll send you a new part, or whatever it is.
The support's there.
Yeah,
PrinterBot, they're nice, they're helpful, but they since they don't charge as much, they can't hire as big of a staff, so it's an intern answering your questions. And more often than not, the answer is, why don't you go check out the forums? Because there's a lot of people that have these, and you can post pictures, and then the people that are using them will answer your questions. They'll send you the parts, it'll just take a little longer. So you don't get quite the level of support with the cheaper printer.
which ones did you all ask for in the grant?
We asked for these. The idea behind the grant was we were gonna do it as cheaply as possible, so that we could train teachers on how to use them too,
Right.
and bring them in, and then they can potentially afford maybe a $600 printer more than a $2,500 printer. That's all.
We also got, and we've had very success with it, we got a 3D scanner, which basically looks like a record player, and it's got a laser on it, and it rotates ever so
Yeah.
slightly and scans the profile of the object. I think it takes about 20 minutes to scan, and we have a couple students that are, again, it's a tool. We have one student who is designing a rock gym for her senior capstone. She's a climber, and she's got this 40-foot rock wall, and she was experimenting with modeling it out of clay, and then scanning it, and then she could take that digital file and put it into her computer model that she's using to actually represent her design. And so it's a way to take things that are analog or physical and digitize them to incorporate into other digital software.
And then it gives a 3D picture then?
It's a three-dimensional object that you can print out. So
Right.
when we were calibrating it, we scanned a cow keychain. This is half the cow. If you ever want to know what half a cow looks like. And so we scanned the cow and then we printed it out to see. And it was remarkably similar. What you lose is variation in color that a lot of 3D objects have, because this is monochromatic. So if you wanted something that looked realistic, you then have to go back and finish it with paint or with something else.
Is everything that's solid like that have the honeycomb inside? Is the honeycomb is how it comes out?
So it's not heavy.
Yeah, and it's
You can actually, you can choose.
Eric
Oh.
can choose, because he's got something that's a little more flexible. I don't get to pick, it's always a honeycomb.
Again, that's where you get the ease of use of his, where it's more plug and play.
Someone said,
See, you don't have a computer hooked up to it.
no, it
Imagine
actually
an
is
SD
operating
card.
off of a camera card, an
Oh
SD
my.
card.
Wow,
I have to have mine hooked up to a computer,
right.
and that runs all the
Right.
software. I get tons of choices, so I can tell it to go faster or slower, I can tell it to fill in little circles or rectangles or honeycombs. I can have it.
You know, dentistry and making like bridge work and molds and,
Dentists, they're
I was
using it
gonna
a ton.
say, medicine.
I think there's, I think probably at some point, they may not end up in your home, but you might be able to send a digital file to somebody that would print it and mail it to you for $1.50.
There is a service called Shapeways that will do that.
Wow.
Someone's already thought of that.
They're expensive.
And
Come to me, I'll do it.
Oh, good.
I heard a rumor that Kinko's has 3D printers at some of their stores, FedEx
Huh.
Kinko's.
Radio Shack and Staples are gonna start carrying these printer bombs.
It's great, this is where we're going, so our
Print your own
students,
toys.
You can.
our students.
That's what all my coworkers think I do. Because anytime they walk by my office, I'm playing with
I
hands
saw
or
Yoda,
or
Yoda
cubes
keychain.
or Yoda.
Did Robin get this thing in the faculty scholarship for grant?
I gotta head to
No,
the next
it was
one.
an external grant.
Well, we have external grants in
Thank
that,
you so
so
much.
have her never send it to
Thank
me.
you very much.
It's,
The grant?
we have the faculty scholarship publication, if it was
Oh.
last year.
Yeah, it should be in it.
It was, it was last year.
Robin
We got the,
Right, so, we're on.
You have your other journal things and presentations in there, but,
Yeah.
we haven't sent that to printer yet, so they approved it,
No, this was a big grant.
but this one was.
this one was, I'll check in with Robin and ask her.
This was last.
Unless it's easier for you to follow
Yeah,
up.
So
Yeah.
we'll meet.
This is easy.
Yeah.
Thanks for coming in.
Yay.